Hello everyone. For this video, I am going to discuss to you about resource control, um, particularly resource leveling and cumulative productions, commonly known as the S-curve. All right, so for these lessons, you are going to learn how to apply the control process and how to monitor the project status of a project. We are going to define what is a resource and how you're going to perform uh, resource leveling and allocations. All right, so what is a resource? Resource is defined as the items or elements that are necessary to meet the objectives or goal of the projects. In the construction industry, these are what we call as the four M's. So what are the four M's? The four M's pertains to materials, money, machineries, and manpowers. So those are the four elements that we will be looking at as a project managers in order to put our project on track at all time. All right, so what is a resource allocations and what is um, resource leveling? We are going to define that in a moment. Alright, so here, resource allocation, it is the assignment of the required resources to its activity in the required amount and timing. It is also called as the resource loading. As a project manager, it is your job to assign the appropriate resources to a particular task or activity in order to uh, be efficient and more effective. And when we say efficient, that is reducing waste in time, waste in materials, or waste in money. So what about resource leveling? Resource leveling is minimizing the fluctuations in day-to-day resource use throughout the project. So what does that mean? Say for examples, you have five resources at the beginning, and then in between the project starts and the end, you reduce that into two or three. That is what we call as fluctuations. Our goal in the construction industry is to create that smooth flow of resources. That's why we usually start with fewer number of workers, and then we add them continuously, and then later on at the end, towards the end of the project, we usually reduce the number of resources or workers. So that is the goal of resource leveling, preventing that hollow in between the beginning and the end. Why is it that important? Because if we're going to remove workers in between, and then we will try to get them back again when we need them, what will happen is that what if they will not be available during that time? So what will happen? It may cause delay into completing a particular task or activity. So that's why we need to plan, stay as part of the project planning for you to be able to properly allocate your workers at every given period of time in order to prevent that what we call as the fluctuations. So again, resources, these are the items or elements that are necessary to complete the project. In construction industry, these are the four M's, as we call it: the materials, the methods, the machineries, and the manpower. All right, so how do we level resources? Well, this is a little bit of a combinations of how you do the scheduling, and then we will be adding in the resources, particularly the manpower, into a given activities. So here we have here the step: draw the precedence or node diagram. That is the network diagram that we have learned in the scheduling fundamentals, and then we will be creating the bar charts, and then we will be looking at resource usage by plotting them into a given graph to see at what particular point that we are over allocated. That means there will be a particular point in time that we have more assignments than the available resources that we have. So what will happen to that? So we might need to move some of those activities in order that we will be able to properly allocate our resources. All right, so let's take a look at an example here. We have a project that is broken down into given activities. We're asked to draw the precedence network. We're asked to allocate the required resources, then level them so that the contractor does not use more than, so there is a specific number of workers allocated to that particular job or project. So again, if you assign a particular activity that is more than 6 laborers, that is what we call as the over allocations. And if it is over allocations, we need to look at it and we'll be able to plan out and move some of those activities in order to avoid these over allocations. Alright, so for the sake of this simplicity, we are going to assume that any laborer can perform any given task. Alright, so this is the given activities. We have 5 different activities with the immediate preceding activities, with the given durations, and the number of laborers working at every given activities. Again, for simplicity, activities are being designated in terms of letters, but in reality, those A, B, C, D, E, those corresponding to a specific task. Alright, so the first thing that we're going to do is to draw the network diagram. So to draw that, as a rule of thumb again, uh, as we have in your project fundamentals, to draw the network diagram, we draw it from left to right, top to bottom. Okay, so in this case, we have the A and the B are activities that are concurrent, starting activities as we call it, and we have the activity C and D follows your activity A, and your D follows your activity B, and of course your E follows your activity C and D. Once we draw the network diagram, you'll be able to perform the network calculations. We call it the forward and the backward calculations. So start with 0 because these are all starting activities. Then 0 plus the activity duration, that gives you 5. 0 plus 7, that gives you 7. And as you move forward, consider the maximum. So here, although your activity D is coming from activity A and B, whichever is the latest or the maximum in numbers in the early finish, that's the value that you're going to carry over into the next activity. So in this case, we have here the 5 and the 7. We carry over the maximum and the 7. C is coming from your A, so that's why we only have here 5. Continue adding those numbers, and that will give you a finish date of 14 days. And then move back. We call it the backward calculations. We subtract and we consider the minimum. So whatever the early finish of the activity or the last activity, that also the uh, project durations, and that will also be the latest finish of that last activity as well. So 14 minus 2, that gives you 12, and then we have here 12 here and 12. And again, as you move backward, consider the minimum, and in any given network diagram there must be always a critical path out. So in this particular case, we should be able to find the critical activities here. Now, as you've learned in the fundamentals of scheduling, the critical activity correspond to those activities that has both at the top and at the bottom that are the same numbers, which means that the early start and the late start must be the same. So in this case here, our critical activities are your B, your D, and your E. Those two activities here remaining, A and C, those are non-critical. Now, why do we need to perform the forward and backward calculations in resource leveling? That is because we need to figure out which activities that has a float time. Now, as you've learned as well, in the fundamentals of scheduling, we have two types of float. We have the total float and we have the free float. So what's the difference between the two? The total float, it is the amount of time that we could delay a particular activity without impacting the overall duration of a given project. The second one is a free float. What is a free float? A free float is an amount of time that we could use to delay a particular activity without impacting immediate succeeding activities. So again, there is a difference between a total float and a free float. The other one, without impacting the entire project duration, so the total float. The free float, without impacting the immediate succeeding activities. So that is the free float. All right, so once you draw the network diagram and perform the network calculations, the next thing you have to do now is to draw the Gantt chart. So to draw the Gantt chart in this particular illustration here, those blue shaded color here, that's the original durations of a given activities. This purple color here corresponds to the number of available flow time. So how do we know? So in this particular case, you will notice in this graph here, we have only activity A and activity C that has the available flow time. Now, if we're going to look back into your network diagram here, activity B, D, and E are critical activities, which means that they don't have any available flow time or amount of time that we could delay. And in fact, those critical path, those are the activities that we need to focus, and we cannot afford to delay any one of those. All right, so it's only your activity A and activity C. As you've learned in the fundamentals of scheduling, to determine the float time is just the difference between the bottom numbers and the top numbers here. Either way, on the late start and the early start, or the late finish and the early finish. So 2 minus 0, that's 2, or 7 minus 5, that's 2 as well too. In the case of your C, that's 9 minus 5, that is 4 days. And that's the reason why we have 2 days float time available for your A, and we have 4 days float time for your C. And again, those are the amount of time that we could use to move or delay the start or delay the completion time of those activities. Now, if we're going to plot the number of resources that we have, because it says here on the given here, we have 2 resources for your A, 4 resources for your B, 3 for your C, 3 for your D, and 2 for your E. To plot that into the graph, on day 1, we have activities that are going at the same time, activity A and B. So we have resources in those, that is 2 and the 4. That's why it gives you 6. So from day 1 all the way to day 5, they're all 6 laborers or workers. But once we get into day 6 and day 7, we have activity B and we have activity C. Activity B has 4 resources and activity C has 3 resources. So that gives you 7 resources for both day 6 and day 7. You need to keep in mind that in the problem, we are only given 6 available resources or laborers at any given time. So in this particular case here, you will notice that shaded red, the 7 here, that means we have assigned a particular activities that is over the available resources that we have. So we have over allocations, as we call it in the construction industry, and that's something that we need to look and repair. And then of course the rest, those are less than 6. Now if we're going to plot that in a given curve, this is how it looks like. Okay, so you'll notice here that we have over allocation here. This is the mark that tells us that we have 6 laborers that we have. So we need to do something for this one here, and to do that, we may need to move some of those activities. Alright, so to do that, we are going to move your C. Why did I choose C to be the activity to be moved? Well, C and A are the activities that has the available time. Remember that activity C, it has 4 available flow time. So in this case here, instead of starting on day 6, I delayed that by 2 days. So it will now start on the 8th day. Alright, in that case, we have here now 6, 6, 6, and we're able to reduce now into a 4, and the rest now still less than or equal to 6. And for us to be able to show again the graph, you will notice here that we have on the 6th and the 7th day, we have only 4 resources. Notice that we have fluctuation here. And again, resource leveling is a project controlling method that allows us to remove any fluctuation in allocating our resources. As I mentioned a while ago, this is one thing that we want to avoid, creating that fluctuation, a hollow in between the durations of a given project. Why is that? If we have 5 resources here, or 6 resources on 5th day, and then you laid off 2 workers, and then by the time that you get into your 8, we'll be needing 6 again. If we are going to recall those 2 laborers, what if they are not available? So what will happen? It may now cause a big problems into the continuity or smooth operations on your project site. So in that case, we need to remove these fluctuations. All right, to remove that fluctuation, we will be doing the same principles of moving or pushing some of those activities that has an available time. All right, so for this case here, remember activity A has a available flow time of 2 days. So what if we are going to move back the start of activity 8 by 2 days, so that it will now start on the 3rd day instead on the 1st day. So in that case, you will notice again, this now become 4 resources for your B, 4 resources for your B, and you have here a combination of 4 resources and 2 resources for your A, and that's still 6. And you will notice here that you have a continuity of having those workers in a longer period of time, rather than we use 6 in the 6 laborers and then we stop. Okay, we laid off 2 or 3 of your workers, and then after 2 or 3 days we recall them again. What if they already find another job? And that will now cause problems into the continuity of your project. All right, so that is what we call as the resource leveling, as we call it, a means of removing any over allocations or removing any fluctuation that may occur during the project. So this is the final graph. So you will notice here there is a longer period of time to where there is a continuity on the usage of 6 workers. All right, so that is what we call as the resource leveling. Okay. All right, so another means of monitoring our project is to determine the cumulative production cost of our project. So what is an S-curve? An S-curve is a graphical representation, an ideal graphical representation of the expenditures or the output or productions of a given period of times on a particular project. This is essential tool for a project manager for them to be able to control their project, to see whether there is an over budget or overruns, as they call it, or if you are behind or ahead of a given schedule. This S-curve or these graphs help us as a project manager to create an evaluations or analysis, to create a critical analysis or solutions to the project. All right, so they call it S-curve because once you grab the expenditure at every given point, it looks like an S, a distorted S. Now, if you have established a schedule at the beginning and the established detailed estimate, you should be able to plot that, and that's what we call as the baseline graph of the S-curve. So that is our idea, and during construction we will be plotting all the expenditures that we have at every given point or every given time. during the durations of the project. And if at some point those line already going above that particular ideal curve, well, it tells you now, gives you a warning as a project manager to analyze it why you're going above that curve. There must be something going on. We are spending 2 months, we are behind schedule. Then as a project manager, it's up to you now to observe, to analyze, or to do something in order to bring back the project on track. Now we have a simple ways for you to draw the the S curve. First is to draw the network diagram. The next is draw the bar chart, and then we will be calculating the cost slope, as they call it, the original the difference between the uh, the uh, the cost divided by a given duration. Draw the cost schedule using the early start of its activities. Alright, so let's take a look at this particular example here. We've given here the total cost and the duration. And the cost slope here is just simply the total cost divided by the durations, okay, for you to be able to calculate the cost slope. Alright, so first thing, you have to draw the network diagram. Again, I am not going to draw it one by one. You already have a background on how to draw the network from left to right. In this particular case, I added because we have 3 different starting activities here. So just to create a one node starting and finish, I added your PS, project start, and a project finish. It's okay as well if you don't have that, but just to illustrate that we have one node at the beginning and one node at the end, which is a good practice to draw a network diagram. Then you may need to do that. Otherwise, if you started with A, B, and C right away, it will still be fine. Alright, and draw the network diagram, perform the forward and the backward calculations. The next thing you have to do now is to calculate the cost slope. To calculate that, what you need to do is just divide your total cost by the duration. So that is 8,000 divided by 4, and that will give you 2,000. And then we have also 2,500 divided by 1, that gives you 2,500. So those are the costs per given day. Okay, and we will be needing those because we will be calculating the cumulative cost at every given point in time. Alright, so once you calculate the cost slope, the next step that you're going to do is to draw the Gantt chart. Okay, so Gantt chart, take note that we have 3 activities that are going at the same time, and then we have your activity E followed your activity B, and then of course we have your activity T follows your activity A, and so on and so forth. Again, take note, if we have a particular activity following, okay, or preceded by more than one activities, you need to follow whichever the activity that has the latest finish time, okay, for you to be able to draw. Alright, so the next thing you have to do now is to mark those earliest start. So in this case here, the earliest start is at 0, okay, and then the next activity that will start soon is your activity E, that is starting on the first day. And the next activity that will be starting soon is your activity D. So that's why we created here this red line, and that will start on the 4th. The next activity that will be starting soon will be activity G and H. So we have here this vertical line here, we're starting on day 9. And then of course the next one will be activity J. This is your next red line. And then the next one will be activity I. So again, we base our cumulative calculation based on the next earliest or soonest activity that will start. Okay, so not the finish, but it's the starting. Okay, so you will notice here those are all on the start. All right, once you identify that, you should be able to calculate now the cumulative cost at every given time. Okay, of course, at day 0, your cost is 0. The next is at day 1. Okay, so we have here cost after day 1 will be the cost to the left of this line here, to the left of this line. So remember that we calculated the cost slope of each of this activity here per day. So in this case here, your activity A has a $2,000 per day cost. That's why we have here 2,000. And then we have activity B, which is 2,000. And then activity C, which is also 2,000. Okay, so that is the cost that we have. All right, and then the next thing you have to do now is the next day now is your day 4. Okay, at the end of day 4, so that's why we have here the next earliest start is after the 4th day. So any cumulative cost to the left of this one here, to the left. Okay. And by the way, I think your B here is should be 2,500 here. So this should be 6,500 on your S curve here. So take note of that one, okay? So this is 2,500. All right, so to the left of your 4th day, that is 1, 2, 3, 4 days for your A. That's why we have here 4 times 2,000. And then we have your B, which is 2,500. And we have your C, that is 4 days, 4 times 2,000. And then of course we have your activity E that has 3 days between the first day to the 4th day. That is 3 times 2,000 here. And that will give you the cost on the 4th day. The next thing that we have to calculate now is the 9th day. Anything to the left of this one here. So the best thing you could do as an alternative is whatever your cost on the 4th day, which is 24,500, just add those costs in between this 4th day and the 10th day. If that helps you as well, make it easier and quicker for you to calculate. Otherwise, you can always go back to the beginning, to the left of your red line here, going to the left. So in this case, the whole of A, the whole of B, and then of course we have your C, that is 9 days. That's why we have here 9. And of course we have your activity D, which is 5 days. Okay, that's why we have here 5 days. And then of course your activity E, which is also the whole of your activity E. So that's why we have here 16,000. And then of course the next one will be on the 13th day. Okay, and once we complete that, you just need to tabulate them into this table here. So on the 4th day, the 4th, the 9, the 13, the 14, the 22, and the 30th. Okay, once you get into the 30th day, that should be equal to the overall cost of the project, which means as a checking, when you add up all of these costs here from A all the way to the N, that should equal to what you're getting here, which is 145,500. To calculate this percentage, you just need to have your cost on the first day divided by the total cost. In this case, the total cost here is 145,500 times 100%, and that gives you 4.5. So 24,500 divided by 145,500, and that will give you 100%. Once you calculate that, what you have to do now is to graph them, plot those points. At day 1, we have here 4.5%, or in the case of the cost, on the first day, 6,000. So plot that wherever that 6,000 here on the first day. And on the 4th day, we have here 24,500. And on the 9th day, we have here 54,500. Once you put a dot on those coordinates, what you to do is just connect those data. Okay. Another way for you to grab them instead of the cost, you could also plot them in terms of the percentage. In this case, I plotted them in terms of the percentage. Again, that is the S curve. Now, why is this necessary for the project manager? Because at the beginning, you should be able to establish this S curve here. And during the construction stage, at every given point in time, you will be figuring out how much you're spending at every given point. Say, for example, if you need to add up all the expenditures that you have on the fifth day and your value is above it, the percentage of that is above the curve, something's going on the job site that you need to investigate. Maybe you are spending too much, or you're wasting material, or you have spent too much on equipment, or your laborers, or your materials. Okay, and that's something that will warn you as a project manager to look at what's going on the job site. And if you continue to be above that graph, well, as a project manager, it is your job to do something. You have to always bring back your project on track. That's the other way for you to check whether, how do you know whether a particular project is on track or not. That is the purpose of the S curve, for you to tell your boss that we are on track. And of course, your plotted points should be within this ideal curve here. Otherwise, if they are above, there's something wrong. If you are below that, maybe you're saving monies, or probably you are ahead of a given schedule. Now, if that is above that particular curve, well, as a project manager, you have to do something. It's either you are going to add workers to bring it back, or probably you have to do some overtime, or you may be employing some shifting on the job site just for you to be able to bring back the project on track. So again, that is what we call as the project resource and project controlling. It is very essential, and it is one of those functions of the project manager. And by the way, as your goal as a construction science and management student, your goal is to learn as much as possible the different functions, the various functions of project managers. And in fact, on this course, the construction management, it gives you an overview of the fundamental functions of a project manager. So what are the fundamental functions of a project manager? Managing, coordinating, estimating, scheduling, and project controlling. So those are the basic function of project managers. So if I were you, and if you want to become a successful project manager in the future, make sure that you learn those basic five fundamental functions of a project manager. So, all right, guys, that is for today, and that's what we call as the project controlling and project resources.